Okay, this is lesson 5.5, factoring quadratic expressions of the form ax squared plus bx plus c. This time we're doing it when a isn't 1, so there's going to be something in front of x squared. So we can't jump right to the brackets like we did in the last video. We're going to actually have to use a process called decomposition to factor. So steps are fairly similar at the beginning to last time. We're factoring out a greatest common factor if there is one, so we're going to look for that first. And then we're looking for integers who multiply to something and add to something. There's going to be a slight twist on what they have to multiply to this time. And then we're going to do a decomposition step. I'm going to show you how to do that through the purposes of an example. And then we're actually going to use factor by grouping, which will allow us to finish factoring this question. Now, this strategy can be used for factoring trinomials that you saw in the last lesson, but it shows a lot of unnecessary steps for the last lesson that you don't need to do because you can jump right to the brackets. But this method will work for all factoring questions that are for trinomials. So let's give a couple examples a shot and see how we go from there. So we're going to factor 6x squared plus 11x plus 3. What's different is we can't go right to the brackets with starting with x and x because x times x doesn't give us 6x squared. So the way we accommodate for that is we're still looking for things that multiply to something and add to something. It's just what they have to multiply to in this case is not going to be 3. It's going to be 3 times whatever a is. That's why it says AC, whose product is AC, because we've got a x squared plus bx plus c. So a is 6, c is 3, 6 times 3 is 18. So we're going to look for numbers that multiply to 18. The adding to step is still the same. We're going to add to 11. And if we've been factoring, now I'll write AC in front. Multiply to AC, add to B. Now if we're getting better at factoring, we might be able to figure out these numbers without writing down a big list like we did in the last lesson. We might be able to think, okay, what multiplies to 18? Well, 1 and 18, that doesn't add to 11. 2 and 9, that does add to 11. Our numbers are 2 and 9. And now as we get better at factoring, we can get to these numbers a little bit quicker, and that's hopefully what we're getting or working towards. Now, we can't go right to brackets and say x plus 2, x plus 9, because that doesn't work. That wouldn't be the factored form of our trinomial. But what this allows us to do is use a process called decomposition. Decomposition means to break down. So what we do is we break down this middle term into two terms. We keep 6x squared, we keep 3, but we break 11x down into two parts. The two parts are 2 and 9, but since this is an x term, it's 2x and 9x. And that's called decomposition. Now what's this allow us to do? Well, this now allows us to factor by grouping, which we learned in a previous video. To factor by grouping, we group the first two and the last two, or we can reorganize. We could switch these two and group a different pair. It would still work. And now we common factor. So what's common to 6x squared and 2x? Well, in terms of numbers, 2 would work. We could divide 2 into both those terms. And for x squared and x works. We can divide out an x. So our common factor is 2x. If we divide both of these by 2x, we would end up with, well, 6x squared divided by 2x. 6 divided by 2 is 3. X squared divided by x would leave us with just x. 2x divided by 2x would be 1. And now we have to common factor again, but this time from our second group. What's common to 9x and 3? Well, both terms don't have x's, so there'll be no x in common. What number can we divide into both 9 and 3? The answer is positive 3. And that leaves us with, well, let's find out. 9x divided by 3 would be 3x, and 3 divided by 3 would be 1. And now if you notice, the brackets are the same. So now we can common factor this bracket and write 3x plus 1 as our common factor, And what's left over is 2x plus 3. All right. So this is the factored form of this trinomial. There's a lot in this example. The nice part is, the only part that should be new is breaking down the 11. We've worked with multiplying and adding, except we're multiplying to something different this time. And we've done grouping and common factoring. So the only new step is breaking down the 11. So if it's the breaking down the 11, trying to figure out what to break that down into, that's new knowledge. So that's stuff that we can work on in this video. If where you're getting stuck is the grouping stage and the common factoring, we should go back and revisit the grouping and common factoring video, because that's what this is. So when we work through these examples, ask yourself where you're getting stuck. Is it the breakdown step, or is it the last part? If it's the last part, we can go back and watch the common factoring video. All right, let's try another one. B, 3x squared plus 8x plus 5. Is there a greatest common factor? Well, there's not x in every term, and there's no number that we can divide 3, 8, and 5 into because, well, 3 and 5 are both prime numbers, so no chance there. So no greatest common factor. So now we're looking at A, C, and B. We're multiplying to AC and we're adding to B. B is 8, and A times C would be 3 times 5, which is 15. So now we're asking ourselves, what multiplies to 15 and adds to 8? And sometimes you get lucky. What multiplies to 15 and adds to 8 is, well, 3 and 5, and they're right there in the question. So now that we've figured out our pair, we do decomposition. We break that middle term down into 3x and 5x. So now we have an expression that reads 3x squared plus 3x plus 5x plus 5. And now we group and common factor. Group the first two, group the second two. So what's common to the first two? Well, 3 is common to the numbers, and x is common to x squared and x. What's that leave us with? Well, 3x squared divided by 3x. 3 divided by 3 is 1. X squared divided by x is just x. In our last term, 3x divided by 3x is just 1. Second pair. 5x plus 5. What's common there? 5. 5x divided by 5 is x. 5 divided by 5 is 1. And now we have the brackets the same. So we can common factor the bracket, x plus 1. And what we're left with is 3x and 5. And there we go. We factored again. Now, if we can't find a pair that multiplies to 15 and adds to 8, that means that this isn't factorable. Sometimes it's hard to find the pair, so that we might have to go back to writing the list. But if you've written the list and you've gone through it and you've remembered all your positives and negatives, and there's no pair that works, you write that this is prime and it won't factor. But generally I'll give you questions that are going to factor. Okay, I'm going to leave example C for you to try on your own, but I want to visit example D because there's a common factor. If we look, this time we have a greatest common factor. If you ignore the greatest common factor, the question is much more difficult, and at the very end you're going to have common factors as a part of your answer, which you would have to then take out. So it's easiest if you take it from the beginning because it makes the rest of the factoring easier. So always look for greatest common factor first. What can divide into 12, 8, and 4? The answer is 4. So we start by writing down our greatest common factor and then dividing each of our terms by 4. 12 divided by 4 is 3. Negative 8 divided by 4 is negative 2. And negative 4 divided by 4 is negative 1. And now we're working with a question that has much smaller numbers. So when we look for what multiplies to AC and adds to B, our numbers that we're working with are going to be much smaller, so there's going to be less possibilities that we're going to have to examine. AC. A is now 3, and C is now negative 1. Before it was 12 and 4, negative 4. So, sorry, 3 and negative 1. 3 times negative 1 is negative 3 and adds to negative 2. So now we're asking what multiplies to negative 3 and adds to negative 2. Well, there's only two pairs that multiply to negative 3, and it's 1 and negative 3 or negative 1 and 3. And the pair that works is negative 3 and 1. Negative 3 times 1 gives us negative 3. Negative 3 plus 1 gives us negative 2. So now we keep the 4 and we do decomposition. We break that down into two terms. 3x squared, first term is minus 3x. Second term is 1x. I'm just going to write x. And our last term is minus 1. So now we group. Keep the bracket and common factor. What's common to these two terms? Well, 3x is common. And it leaves us with x minus 1. What's common to these two terms? Well, there's no common factor. So what we do is we write plus, and if you'd like to write the 1, that's fine. If you don't, that's okay. You can just write plus bracket x minus 1. X minus 1 is prime. There's nothing common between x and minus 1. So we can write plus 1 if we want to. How do we know it's plus 1 and not minus 1? Well, whatever the sign is here. So since it's a plus x, we write plus 1. If it was a minus x, we'd write minus 1, and we'd have to common factor a negative from both terms. But it's a plus 1, so we'd write plus 1. Now, our brackets are the same. So we can write our bracket down. And what's left is 3x plus 1. And what's neat is this looks more complicated, but if you cover up the 4, this is the exact same as the process we used for every other question prior to this. It's just a little bit trickier now because we have this 4. The easy way to organize it in your head is 4 with the bracket around the expression. You can kind of ignore that all the way down, and then the question is just the exact same as any question you've already done. Okay, so don't worry if you have a greatest common factor. It's just writing an extra number in front of the whole process. In fact, if you really don't like it, don't write the 4, and then at the very end, just go and add a 4 at the beginning and write a big bracket around everything you've done. All right, last example. This example looks different, but you see this commonly. Now, this isn't a quadratic anymore. This is just a trinomial. What's different is we have two variables. We have x's and y's. But if your x's and y's follow this pattern of x squared, xy, y squared, x squared, xy, y squared, we can factor this the exact same way as we just did. It has to follow the same pattern, though, x squared, xy, y squared. And the way we factor is just decomposition. We ignore the letters and we just work with the numbers. So is there a greatest common factor? First off, 2, 9, and 4. Well, 2 is common to these two, but not 9. And there's x's in the first two, y's in the second two, but there's nothing throughout. So there's no greatest common factor. So let's look at AC and B. We want to multiply to AC and add to B. So that's multiply to 2 times 4 is 8, and add to 9. Well, the numbers that multiply to 8 and add to 9 are 1 and 8. So how do we factor this? Well, we do decomposition. We break down the middle term. Start with 2x squared. First term is 1, so it's 1. And since our variable is xy, we write xy. The second term would be 8xy, and our last term is 4y squared. So the only difference here is the middle term is, instead of just having x's like it did in a previous example, since the middle term is an xy, we break it up into xy's. And now we group and common factor. What's common to the first two terms? Well, there's an x in both terms. And if we common factor an x out, we'd be left with 2x plus y. What's common to these two terms? Well, there's 4 can divide into both 8 and 4, and there's a y in both terms. So 4y, and it's plus. And if we divide 4y out of our terms, 8 divided by 4 is 2. Xy divided by y just leaves us with an x. 4y squared divided by 4y, well, that would just leave us with a y. And if we look, our brackets are the same. So we can common factor that bracket. And what we're left with is x plus 4y. And there we go. We've factored a trinomial. I'll leave B for you to try. And be sure to check your answers on the course website for C from example 1 and B from example 2. Thanks for watching, and I'll see you next time.